We have a T flip-flop, we want to convert it into a D flip-flop. So we will have our D input here, there will be a combination of gates here, and output of that will go to the T input, and Q will come as a feedback input in this combination. So this will have a combination of Q. So our T input will be function of Q and D. So if we look at the truth table of a D flip-flop, we can write like that: QT plus 1, which can also be stated QP, Q present state, Q next state, like that. So let's do that: 0 0 0 1 1 0 and 1 1. So if D input is 0 and present state is 0, both are 0, the next state will be 0. Now we know that for a D flip-flop, whatever is at the input with the clock, it goes to the output. It doesn't matter what is the present state, the next state is always whatever is at the input. So we can just copy this column into the next state. So 0 0 1 1. So that's how it will be if it is a D flip-flop. Now if for T input, we will look at the next present state and next state, and we will say what will be the T inputs which will give that next present state and next state, the present corresponding next state for a present state. We will have to see. So present state 0, next state 0 for the first one. So that means T input will be 0 because it is no change. For the second one, present state is 1, next state is 0. That means it has changed. So T input will be 1. Here also, the third one also, it has changed from 0 to 1. It has become, so the input will be 1. For the last one, both are 1. That means no change. So this is again 0. T input will be 0. Now what we will do, we will write the expression of T looking at these two columns. And here maybe I will use a different color. So when we look at the truth table, we will write the sum of products, of course, for the ones. So there is a 1 here, there is a 1 here, and the corresponding D and Q combination is this one and this one. So for the first one, it will be D bar times QT. So T will be D bar times QT. The second one plus this one, this will be D and QT bar, D and QT bar. So this means that D XOR QT is just like the previous one. That when we wanted to convert a D flip-flop into a T flip-flop, it's the same expression basically. So what we need to have in this unknown box is an XOR gate. Sorry, this one will be an XOR gate like that. So that will be the combination. So Q will come back here as an input to the XOR gate, and this is our D input, and this output will go to the given T flip-flop. So this is the T flip-flop, and this whole thing is the D flip-flop, which is the converted D flip-flop basically. And this is the system, this is the clock of the flip-flop, the same clock.